Right. Hello everyone, I'm Taejun Kim and I'm glad to present QuadStretcher project, a skin stretch display for immersive barehand interaction in AR and VR. This project was done with my collaborators at KAIST and UNIST, Youngbo, YoungIn, Sunbum, Jaeyeon, and Geehyuk. Okay. So with the advancement in hand tracking technology, commercial AR and VR headsets now support seamless barehand interactions. And in the meantime, we face a challenge in delivering haptic feedback to users' hands without encumbering the hands. Previous research often suggested ways to provide haptic feedback direct to the hands, such as using grounded haptic device, hand-worn device, or handheld device. However, these direct feedback methods are not applicable to barehand interactions where the hands must remain bare. In response to this challenge, field research has proposed a promising solution of employing haptic feedback on the wrist and forearm area as an indirect approach. A pivotal study by Peasant et al. Suggested providing squeeze stimuli to the wrist with the aim of delivering substitutive haptic feedback when the bare hands are interacting with virtual objects. With the TASB, the authors tested various AR and VR interactions, and this substitutive haptic sensation integrated with visuals was reported to significantly enhance the user's immersion level. However, as noted by the authors in their paper, the squeeze expression of TASB was essentially 1 degree of freedom, either in the squeezing or releasing direction. So here we present QuadStretcher, a skin stretch display featuring 4 stretching units surrounding the forearm. And each stretching unit can expand together, contract together, or pose-independent control. The stretching unit has 2 counteracting tactors, and each tactor was driven by a servo motor by a rack and pinion mechanism. The tactor can expand or contract 11 mm at maximum under no load. Tactor speeds reach up to 206 mm per second, and in other words, it takes up to 53 milliseconds to reach the max expansion or max contraction. This artifact is a result of an iterative design process, opting for longitudinal skin stretching rather than lateral to better reflect the biomechanics of forearm muscle tendons, which contract and expand in the longitudinal direction of the forearm. And furthermore, the novel aspect of the QuadStretcher is that it does not employ a base frame, which is a common practice in the design of stretch actuators for firm grounding. Instead, we rely on the counteracting tactors for grounding, so avoiding the bulkiness. We also provide thorough specs of the QuadStretcher in the paper, including the range of actual skin displacement, range of comfortable stretch output, psychophysical investigation of Jaeyeon, and confusion matrix of possible stimuli set. For details, please check out the paper. Then we prepared various barehand interaction scenarios for testing, which covers a range of hand motion primitives. 1DOF interactions were designed to represent simple hand motions that elicit a 1DOF value, such as the amount of button pressed, the degree of knob rotated, or the extent of sprayer triggered. We tested 2 stimuli rendering options of either contracting all 4 stretching units or expanding all for the amount of this 1DOF value. So in the preliminary user study, the all contract option was the most preferred choice, so we opted it for the final design and used it in the final evaluation. And for more complex hand movement, 3DOF interactions were designed. Pull rubber band represent a scenario of position-dependent force, and hook fishing rod represent a velocity-dependent force that covers for upward and downward hand movement. And lastly, swing tennis racket is also a velocity-dependent force, but with left and right hand movement with tennis swings. So let me quickly describe the stimuli rendering algorithm for 3DOF interactions. On the top image, it shows a real-time force vector visualized. And the x-axis was the non-directional component, which is the arm movement either forward or backward in relation to the origin of the band. So this was mapped to the all-contract scheme, similar to 1DOF value. Then the y-axis was the horizontal component, which is the arm movement to the right or left from the rubber band origin. Here we tested two different rendering schemes. First, in contract towards force rendering, when the rubber band was pulled towards the right, the force vector acts towards the left. So the left stretch module contracts and the right stretch module expands. It's an approach to render the force vector by contracting towards the force. The contract away from force was opposite. In the formative user study, almost all participants preferred contract towards force rendering as a better metaphor of the force vector expression. So we adopted it for the final design and used it in final evaluation. To continue, the y-axis value of the force vector was converted to the control signal of the QuadStretcher with the contract towards force rendering. Similar to that, the z-axis was the vertical component showing the arm movement upwards or downwards. So when the user pulls the rubber band upwards, the ventral stretch unit contracted and the dorsal stretch unit expanded. Finally, each component of the force vector contributed to the calculation of the final control signal. So finally, we conducted the evaluation of QuadStretcher in comparison with the baseline solution squeezer. The squeezer was reproduced from the base design element of task B. So please refer to the paper for more details about the implementation. User study participants explored all 6 VR interactions with each haptic device as much as they wanted. And for the stimuli rendering of the squeezer, only the magnitude of the force vector was translated to the extent of squeezing, regardless of the direction of the force. And once ready, participants verbally provided ratings for the 4 metrics on a 7-point Likert scale. Metrics were realism, immersiveness, enjoyment, and only for 3 DOF interactions, perception of force direction. And 20 participants were recruited and the experiment was repeated measure design with the order of condition counterbalanced across participants. So yeah, as a result of the evaluation, participants favored the QuadStretcher over the squeezer across all metrics in complex 3DOF hand interactions such as pull rubber band and swing tennis racket. Especially in terms of the force direction perception, QuadStretcher provided superior experience than the squeezer, which is somewhat obvious considering the expressive capability of each device. There was no significant difference observed in 1DOF hand motions such as push button, rotate knob, and trigger spray scenarios, which didn't really take account the expression of the force direction. So finally, we could confirm that the QuadStretcher is capable of supporting immersive barehand experience, especially for interactions with higher degree of freedom dynamics. Many participants explicitly mentioned that they could feel the distinct feedback between tennis swing direction or band pulling direction. So for more detailed qualitative user feedback, please refer to the paper. So lastly, we share design takeaways that we distilled from the user study for the future development of forearm haptic solutions. First point is about the inherent difference in sensation. So aside from the degree of freedom that each device can express, skin stretch and squeeze are inherently different haptic modality. Consequently, participants expressed unique feelings that each type of haptic stimuli conveyed. For instance, P8 mentioned that the QuadStretcher better describes the tautness of a thick rubber band. And at the same time, P8 also mentioned that the QuadStretcher was more delicate texture, like water spreading out from the sprayer. P7 also said that squeezer feels softer and more continuous, while the QuadStretcher was more resisting feeling. Overall, participants typically felt that the squeeze was more suitable for softer sensation, while the skin stretch was better for expressing resistance, such as pulling or pushing an object. So, the unique sensations offered by different haptic modalities should be considered and may better suit a specific target application for enhanced user experience. Yeah, next point is about the worn location of this indirect forearm haptics. We note that the two devices were worn at different locations. The existing solution of squeezer was proposed as a wrist-worn device, while the QuadStretcher was designed for the longitudinal stretching of the forearm. So we elucidated this design factor and the corresponding user experience through the interviews. In general, participants found the QuadStretcher more natural when they thought the interaction required force on the entire arm, such as when swinging a tennis racket. On the other hand, they considered the squeezer more natural when they believed the action is mostly about the wrist, such as when rotating a knob. So the takeaway is that the optimal stimulation area may differ depending on the target barehand activity. Therefore, taking into account these locational aspects can be beneficial for the AR and VR haptic application design. And the last point was about the individual mental models in the ways of perceiving the haptic stimuli. In the interview, some participants said that the sprayer was requiring the active use of the arm muscles, so the skin stretch on the forearm was more realistic. But on the other hand, another group of participants said that the sprayer barely engaged arm muscle, so the simple squeeze on the wrist was more natural. And these contrasts show how the interpretation of anticipated haptic sensation can influence user satisfaction. So the last takeaway is that consider the diverse mental models that can be possessed by different individuals. And providing a unified description of the haptic feedback for a particular action may balance the user interpretation, such as describing like, when you trigger a sprayer, this haptic feedback will express your arm muscles engagement. Okay, so to wrap up, we proposed a novel artifact called QuadStretcher, and we contribute to the design of future forearm haptic solutions for immersive AR and VR applications. This is the end of my talk, and this project has been archived for open hardware in the shown GitHub page. Thanks very much.